So the word system simply means to us two or more equations or two or more inequalities. Obviously, in this case, because it's linear inequalities, it's two or more linear inequalities. So here it says a solution to a system of linear inequalities is an ordered pair that satisfies all inequalities within the system. Satisfies, remember, means makes the inequality true. It says graphically this will be all the points that are found in overlapping shaded regions. Okay. It says you will benefit from using colored pencils while doing this. I'm going to show you how to do this by hand initially, and then I'll also show you how to do this using Desmos. Okay, so working with this first example. Okay, what we're going to have to do is we're going to have to first understand what it means to graph a line, which we've done before. And as we go through these examples throughout this, there are different versions of kind of equations for us right now. This first one is in y equals mx plus b form, right? Okay, so I'm going to use that technique. So as we go through, my hope is that we use techniques that the equations set themselves up for, the way that they're developed. Okay, and you'll see then the benefit of learning all of that stuff in the beginning of the chapter. With equations and graphing lines, you can see that kind of stuff pay off. So if I want to graph this first one, I'm going to go, my y-intercept is what number here? If we're graphing that one there, y-intercept is, yep, okay, so then we got to look at the negative, right? So -3 is my y-intercept. I'm going to go down there and plot that point. All right, and now my slope, what is my slope for this particular one? 2. And as I rise over run, it's 2 over 1, right? Yeah. So I'm going to go up 2, and then to the right 1. Do that as many times as you need to get yourself enough points to get a good line. We make our line. Let's see here. The line is actually why won't that work? There we go. So there's my line. Does anybody remember when we graph inequalities, what we do? Because we did this in Algebra 1, okay? What we do with a less than sign when we graph the line. Do you guys remember that it actually becomes a dotted line? Ever seen that before? Yeah. So I'm going to try to do that here for us. Make this dotted. Okay, so that is y less than 2x minus 3, almost. Okay, we still have one more component to do. Okay, when we graph linear inequalities, we also have to shade a part of our graph. Okay, now there's a couple ways of doing this, but I think the easiest, safest way is to choose a point that is on our graph, okay, just on the entire XY plane, and plug it in here and see if you get a true statement or a false statement, okay? So a really nice point to choose is 0, 0. If I plug 0, 0 in for this yellow inequality here, I get 0 is less than, now putting 0 right there makes that go away, right? And then I get -3. So is 0 less than negative 3? No. Okay, that's false, right? False or no, however you want to say that. So that means if we get a false statement, we do not shade on the side of the line that that point came from. Does that make sense? So you see at that point came from the top side of that black line. So then what we do is we shade on the other side of that line. If we would have gotten a true statement, we would have shaded where that point came from. Okay, so I'm going to write down some facts here that maybe we should also write down. If we are graphing the line, okay, so I'm just going to write type of line here. Type of line. Dotted if you use less than or greater than. Okay? It's solid if it's less than or equal to or greater than or equal to. You know, I'll write down here where to shade or color. I want to write it. There's several techniques. So the first technique, use a test point. Use a test point and substitute into the inequality. Okay, if you get a true statement, shade on the side of the line that the point came from. And if you get a false statement, that didn't work the way I wanted to. If a false statement you shade on the opposite side. Of the line. Okay? That is the most direct. Zoom out here. That is the most direct way, the most algebraic, most mathematical way of determining where to shade. Because that's exactly what our shading tells us. Our shading is essentially a listing of all the points, all the x comma y's that would satisfy this, that would make this yellow statement true. Okay? So let me give you kind of an example of that. If I chose the point, over here would be 3, let's go 3, 1. 3, 1 is in the region that I shaded, right? Okay? So that means if I would plug the 3 and the 1 in over here for x and y, so plug in the 1 for y, so this point here is 3, 1. Plug in the 1 for y, less than, now 2, now x is 3 from this point right here, and then minus our 3. So I get 1 is less than 6 minus 3, which 1 is less than 3, right? Is that true? That make sense? And that's why we shaded over here, okay, where 3, 1 came from, because it gave a true statement. What it means is every one of these points that is shaded blue is representing an infinite number of these red points that I could choose. No matter what one of those points that is inside that blue, you could pick it out and you can plug it in this yellow and it will give you a true statement. Does that make sense? You may have questions on that. Okay. Another, yeah, go ahead. Yes. Yep. Another way to determine where to shade. Now this is only if my inequality has y solved for, and y is coming first. Okay. Like if I have like y equals mx plus b, and I say y is less than mx plus b. If you draw your line, so let's say that my line looks something like that. Okay. Would you guys agree that it gives me a, if I'm looking at the dotted line, it gives me a top side and a bottom side of my graph? Does that make sense? Okay. If it says y first and then it says less than, you're going to shade the bottom. Okay. And that's exactly what we did right here. We have y first, it's less than, and this would be the bottom of the line. Some people, the steeper the line is, some people struggle with determining what's the bottom, what's the top. I always put myself kind of at the, gotta do it this way. If I put myself like dangling above my graph, okay, and I drop myself in on the graph, I should always land, when I interact or intersect with the dotted line, I am going to land on top of the line. Does that make sense? So where my person is right there is the top of that dotted line. And if I need to shade the bottom, then I shade on the opposite side. So you can use that kind of technique if you need to. Okay, but that only works if y is coming first and y is solved for. Okay? They're okay with that idea? No, we're good? Positive? All right. Now, that was just that first inequality. Now what I want to do is I want to graph this second one. Okay? So if I want to graph this second inequality, you've got options. I'm going to do it first by using, because this is set up to allow me to find my x and y intercepts pretty easily. If x was 0, can we agree that that would go away? And I'd be left with, now, I haven't maybe said this yet, but when we're graphing these, we're going to assume right away at the onset, like these are equal signs. Okay? It's not until we actually put into the graph that we actually, and we do the shading and the dotted line, solid line, that we really pay attention to the inequality. So if x was 0, y would be 2, right? Does that make sense? If y was 0, it would go away. And you just left me with 2x equals 2, right? So if 2x equals 2, what would x be? (2x equals 2), what's x? X is going to be 1. So now I've got 2 points that we can graph. We're going to graph 0, 2, which is right there. And we're going to graph 1, 0, which is there. Okay? I can connect those. All right, and because now it is a greater than symbol, okay, our ruler here said if it's greater than, then you have to use a dotted line. So again, I'm going to go back to a dotted line. Do this in red here. So we got our dotted line. Now we need to shade on a particular side of this line. So if I'm going to shade on a particular side of this dotted line, I'm again going to choose 0, 0, and I'm going to plug it in here. If I plug 0 in there, it gives me 0. Plus plug 0 in there, it gives me 0. And I ask myself, the 0 plus 0, is that greater than 2? Is that true or false? That's false, right? So if it's false, I do not shade where 0, 0 came from. So there's two sides of this red dotted line. 0, 0 is on one side, and all the points now that are on that side would all give me a false result. But on the opposite side, they're all going to give me a true result. So I'm going to go to the opposite side, and I'm going to shade over there. So all of this would be on the opposite side of the red dotted line. Is that okay with everybody? Now when we do that, what happened to part of my graph? It started to change colors, right? Okay. That overlap is the solution to this system right there. Okay. These are the points that are going to make that system true. Okay. The points that are yellow, let me highlight some stuff here real quick so we can talk about it a little bit easier. The points that are yellow are only going to work. Heck. The points that are yellow are only going to work for that one. They're only going to give true results for that one. The points that are blue are only going to work for that one. Does that make sense? Only give true results for that one. So if I chose like this point right here, let's go, so 1, -4. If I go 1, -4, I go -4 there. 2 times 1 is 2, minus 3. I get -4 is less than -1. Is that true? Is -4 less than -1? So that point right there satisfies that inequality. But if I plug it into the yellow one, 2 times 1 plus a -4, is that greater than 2? Is -2 greater than 2? That's false, right? So we see that that point right there gave me a true statement for the blue inequality, but it gave me a false one for the yellow. And that's what this graph is representing. Anything that's blue is only going to work for the blue one. Anything that's yellow, so that point right there, that's only in the yellow, so it's going to give me a true for the yellow, but it'll give me a false for the blue. Yellow and green, or sorry, yellow and blue together make green, right? So any point that is in this green is going to work for both of them. It'll give me a true statement for both of them, okay? So let's try a point there that is in the green. So I'm going to use a nice point here. Let's just go 6, 0. 6, 0. So if I plug 6, 0 in, so the x is 6, the y is 0. So in this first one, I would get, see if I can give myself some more room over here. If I plug 0 in, I get 0 is less than, plug 6 in for x, so it's going to be 12 minus 3. And if I plug into the bottom one, 6 and 0 again, I get 2 times 6 is 12, plus 0, is that greater than 2? So this red one says, is 0 less than 9? That's true, right? This one here says, is 12 greater than 2? That's true. And we see we get two true statements. These green points are the only points that are going to give me both true statements. Okay? Does that make sense? Does anybody have questions on this? You guys are kind of quiet with this. Confusing? There's a lot of steps. Okay? And there's a lot of like different things you can do in regards to determining where to shade and that kind of stuff. Here, if I wanted to determine where to shade on that one, by determining top and bottom, I would have to solve for y. So let me answer this and then. So if we were struggling with where to shade, the option of this one here, if I needed to do like top and bottom, if that's how I like to shade, I need to solve for y. So I would say y is greater than, now negative 2x plus 2. Just move that 2x to the other side. And you can see that does give me that red dotted line. So the 2 would be that y-intercept right there. And then down 2 over 1 would give me that point right there. Okay, so it does graph it that way. But now you see that its y is greater than, so greater than when y is solved for first, and we see greater than, that can tell us that we shade on top of our line. So if I take my person and I drop them in on the graph, they're going to land on top of that red dotted line, right? And then you can shade in the yellow. Okay. If we open up your computers to Desmos, okay, if we put those on your like bookmarks or anything like that. So Desmos is DESMOS.com. I'm going to show you the convenience of using this to help us, okay? If I say y is less than, so I hit shift and then comma, gives me the less than, and I go 2x minus 3, see how it graphs everything I needed? Okay, and what is even better is even that second one, I can type in 2x plus y is greater than 2, and it shades all of that stuff, okay? And now all we have to realize, so that takes out all of the graphing for us. It takes out the determination and substituting for where to graph. Now we see the two colors, and the overlap is then what we can concentrate on knowing our solutions. Does that make sense? Okay. Now, if we're going to use that, which is fine, I don't mind using the technology to help us, but we got to know what things mean. Okay. I just don't want you. And I think this happens a lot in math classes, is that you learn, maybe we go back to this, you learn how to do that. Okay, you might become very proficient at that, but do you know what the colors mean? Do you know what the overlap means to us? And that's what I want us to be able to do, okay? If we're going to use our technology to help us graph it, that's fine. But know that what this means is that any point that I choose here, when I substitute it back in, it's going to give me a true statement when I plug it back in. So all of these points that you plug in over here, that are in this purple, will make this true, and it will make that true. Is that okay? All right. Let's stop there.